Let's review for our quiz on 2-3. So here we're asked to find all the zeros, specifically all the real zeros of these polynomial functions. So let's start with number 1. So finding the factors of list of possible rational zeros, we're going to get the factors of this value here, 5, and divide them by the factors of the leading coefficient, which is 1. So 1 divided by 1 is 1. So let's try positive 1. Let's see if positive 1 works. So bring down the 1. This is going to be 1. This is 6. This multiplies to 6. This is positive 5 times 1 is 5 and 0. So yes, 1 in fact does work. Now, with that, we end up with x squared plus 6x plus 5. Now we have 2, and we want to figure out what makes this equal to 0. Now we have two options. We can try the factorization, or we can automatically go into our quadratic formula. I'm going to go with the latter. And automatically just go into the quadratic formula. Again, just so we could practice that formula again. Because remember, this formula works for any quadratic equation set equal to 0. So with A being 1, B 6, and C 5, I'm going to substitute in those values into our quadratic formula. So we have negative of 6 plus or minus 6 squared minus 4 times A, which is 1 times C. And this is divided by 2 times A. Now, I'm going to use the ID4 to figure out what that equals to. So let me bring this out. We have 6 squared minus 4 times 1 times 5. And that's going to equal to 16. So I could have done this using factorization because 16 is in fact a perfect square. So there was a way of factoring this. But the quadratic formula again automatically finds me those factors for me. So we end up again with the square root of 16, that's equal to 4. And now we have our two solutions. We have our solution. Let me write this over here. Let me continue over here. We have two solutions. X is equal to negative 6 plus 4 divided by 2. And the other option is that x equals negative 6 minus 4 divided by 2. So negative 6 plus 4, well, that's negative 2. Divide that by 2, that's negative 1. Negative 6 minus 4 is negative 10. Divide that by 2, and that is negative 5. So our answers are the following. X equals to negative 1, x equals to negative 5, and of course this solution right here that we got at the very beginning, which is positive 1. So those are the three zeros, the three real zeros to this polynomial function. Let's see, let's look at example number 2 now. Same situation here. We want to start by looking for the list of possible rational zeros, which would start by getting the factors of the constant 16. And dividing them by the constant, which is 1. Let's see, let's start with 2. Let's get 2 and divided by 1, that's going to be 2. So let's try positive 2. Let's see if positive 2 works. So 1, 7, negative 26, and positive 16. This is 2, 9, 18, negative 8, and positive negative 16 and 0. So positive 2 did in fact work. So we have 1x squared plus 9x minus 8. And now we want to see what makes this equal to 0. Again, like I said, I'm going to jump straight into the quadratic formula. Because I don't want to struggle, again, being able to determine if this is factorable or not. And it's good practice, again, to use this formula here. So with a, b, and b being 9, we're going to get the opposite of 9. So negative of positive 9 plus or minus 9 squared. Hold on, give me a second. Uh, 9 squared minus 4 times a, which is 1, times c, which is negative 8. This is divided by 2 times a. Let me zoom in a little bit more. And the opposite of 9 is negative 9. And now let's see what this is going to equal to. So we have 9 squared minus 4 times 1 times negative 8. And that's 113. Divided by 2. Well, 113 happens to be a prime number, so there's no way of simplifying this. And it's definitely not a perfect square. If I take the square root of 113, again, I get this irrational value. So we're not going to use that number there. And our answer is going to be negative 9 plus the square root of 113 divided by 2. And the other answer is negative 9 minus the square root of 113 divided by 2. And of course, we also have this value right there. So our zeros, the list of zeros for this one is x equals to negative 9 plus, like I said, the square root of 113 over 2, and then minus negative 9 minus that square root of 113 over 2, and of course positive 2 as well. So these are the zeros to this problem number 2. All right, so now let's move on to the next example again. So right here, again, we have to start by first figuring out what factors we have of 193. So obviously 1, 3, not 193, 93, 3 is a factor. 4 doesn't seem to be a factor. 5 doesn't work. 6 doesn't work because 2 isn't. 7 either. 8 isn't either. And we only get 31, and of course 93 itself. We're going to divide all of that by 1, and let's see what works. Not 11, sorry. By 1. So let's see what works. Let's try. Let's try 3. See if 3 works. So we bring down the 1. Let me zoom in. And that's 1. 1 times 3 is 3. This adds up to 4. This is 12. And 12 plus negative 43, that adds up to negative 31. Multiply that with 3, that's negative 93. And this adds up to 0, so that one works. Again, I'm just going to jump straight into the quadratic formula. And x is going to equal to the negative of positive 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 31. divide that by 2 times 1. And we'll continue over here. So the negative of positive 4, so this right here, that's going to be negative 4. And this, well, let's calculate that. So we have 4 squared minus 4 times 1 times negative 31. That's negative 140. I'm sorry, positive 140. So square root of 140. We'll divide this by 2. And now let's simplify this. We want to simplify this value right there. So let's see what we can use to simplify that. Well, we can break out 140 to, let me do it over here. We can break out the square root of 140 by using the square root of 4 times the square root of 35. And since the square root of 4 is 2, we end up with 2 times the square root of 35. So we can make that substitution for the square root of 140. So we have negative 4, add and subtract 2 times the square root of 35 divided by 2. Now all of these values here have a common factor of 2. So if I divide everything by 2, we end up with negative 2 plus or minus 1 times the square root of 35 divided by 1, which is just simply negative 2 plus or minus the square root of 35. Remember right here, we're multiplying 1 with the square root of 35, so we can just write it as that. So here are our solutions. So our zeros for this example is x is equal to this 3 right here. So x is equal to 3, and then of course this right here that we got, which is negative 2 plus or minus the square root of 35. So here's the solution for example number 3. All right, let's move on to example number 4. All right, so on this example right there, again, we want to now notice again that we have factors of 6 and factors of 4. So let's write the list of possible rational zeros. So the factors of 6 are 1, 2, 3, and of course 6. And we want to divide that by the factors of 4, which are 1, 2, and 4 itself. So let's start by first dividing these by 1. And let's see, let's try 1. Let's see if 1 works. So 4, 12, negative 19, and 6. I don't see this working, but let's try it anyways. So this is 4, this is 16 times 16, and this gives us negative 3. And no, so this one did not work. So 1 didn't work. And let's try the opposite. Let's try negative 1. Negative 4, 8, negative 8, and this is negative, nope, definitely not going to work either. So not negative 4, not negative 1, I'm sorry, not positive 1. So let's look at our list again. 2 doesn't seem to work, because then we're going to end up getting the numbers bigger. 6 is definitely way too big to try. But let's try 2. Let's see what happens when we try 2. I don't see it working again, but let's see. No, you see this is going to be 20, and then 20 times 2 is 40, so no way that that's going to work. And if I do negative 2, then this is negative 8, and this is 4, and this becomes negative 8, and then that's just going to become more negative, negative 27. So again, that's not going to work either. If I try 3, doesn't seem like it's going to work, so I'm going to end up getting bigger and bigger values. And the same thing with negative 3. So it doesn't seem like I'm going to end up using any of those values. So dividing by 1 isn't going to be helpful, right? So now let's get these values here and let's divide them by 2. So let's start with 1 divided by 2. That's going to be a half. So let's try positive 1/2 first. So 4 times 1/2, well, that's equal to 2, and this is 14. 14 times 1/2, that's 7, plus negative 19, that's negative 12, and negative 12 times half is negative 6, and that's 0. So this is our solution. So x is equal to positive 1/2. And now using our quadratic formula with a, b, and c here, we're going to get that x equal to negative of positive 14 plus or minus the square root of 14 squared minus 4 times the value of a times the value of c. Divide that by 2 times the value of a, and we end up with that. Now let's simplify again this. So 14 squared minus 4 times 4 times negative 12, that's equal to 338. I'm sorry, 88. 388 divided by 8. And yep, we can use 4 again. So we can use 4, and we can break this apart. Break this up. Where is it? Here. The square root of 388 can be written as the square root of 4 times the square root of 97. And since the square root of 4 is 2, this is 2 times 90, the square root of 97. So doing that substitution, we end up getting negative 14 plus or minus 2, the square root of 97, and divided by 8. These numbers again can now be factored out by 2. So negative 7, 1 times radical 97, and 4. So our zeros is that x equals to, again, this 1/2 that we start off with. And then again, the two irrational solutions, negative 7 plus or minus the square root of 97 divided by 4. There you go. All right, moving on to example number 5. Let's try 3. All right, as soon as we have a 3 in the front, a 3 in the back, let's try see if 3 works. Again, the list of possible rational zeros divided by, again, 1 and 3. Well, again, let's just try positive 3. See if positive 3 works. This is 9. No, it doesn't seem like it's going to work because it's going to end up becoming 22 and times 3, so no, that doesn't work. So positive 3, no good. Let's see, let's try negative 3. This is negative 9, which is now 4, negative 12, which is 1, and times negative 3, that's negative 3, and that one did work. And again, instead of trying to go into factorization, I'm going to go straight into our quadratic formula. So with a, b, and c being 3, 4, and 1 respectively, I'm going to get the negative of positive 4 plus or minus the square root of 4 squared minus 4 times a, which is 3, times c, which is 1, divided by 2 times the value of a, which again is 3. And we'll continue over here. So all I'm pending right now is this here. So let's see what that equals to. So 4 squared minus 4 times 3 times 1 is equal to 4. And that's perfect. Because 4 is a perfect square, x equals to negative 4 plus or minus 2 times the square root of 6. Again, this is equal to 2. So now we have this value here, and we have two solutions. We have x equals to either negative 4 plus 2 divided by 6, and the other possibility is that x equals to negative 4 minus 2 divided by 6. Again, from this statement right there, we can break it up to those two solutions. So let's see, let's do the negative 4 plus 2. That can be negative 2 divided by 6. That reduces to negative 1/3. And this now adds up to negative 6 divided by positive 6. That's negative 1. So here are the three zeros. So our zeros are negative 1/3, negative 1, and then the one that we did using synthetic substitution, this one right there, of negative 3. So there are our answers. All right, let's move on now to the back side. Let's see, moving on and going to example number 6. So here, the list of possible rational zeros. Our possible rational zeros would be the factors of our last number 1 divided by the factors of 5, which are 1 and 5. So let's start by doing 1 and dividing it by 1 before we get into the fractions. So let's try positive 1. So 5 times 1 is 5. This adds up to 4. Times 1 is 4. This adds up to negative 1. And times into 1 is negative 1, so 0. So 1 is one of our solutions. And now let's find the other ones using, again, our quadratic formula, a, b, and c. Times the value of a times the value of c divided by 2 times the value of a. And let's see what that is. Let's see the square root. So we have 4 squared minus 4 times 5 times negative 1. That's 36. So the square root of 36 divided by 10. Let's continue that over here. So that's going to give us x equals to negative 4 plus or minus 6. Since the square root of 36 is 6, we end up again with two more rational solutions. We have negative 4 plus 6 divided by 10, and then we have negative 4 minus 6 divided by 10. So let's simplify the top parts. So you know what, let me move this, hold on. Let me move this over here, okay? So all I've done is just simply split this again into the two possibilities because of that plus and minus. So if I add negative 4 with 6, that's positive 2 divided by 10. Well, that reduces to 1/5. If I subtract negative 4 by negative 6, that's negative 10 divided by 10. That's equal to negative 1. So our zeros are positive 1/5, negative 1, and of course this one up here, which is positive 1. So here are the three zeros to this function. All right, a couple more to do. The list of possible rational zeros, the factors of 5 divided by the factors of this 5, which again are 1 and 5. So let's see, let's start with, Let me look at the tap problem. Let's start -1. Let's see if -1 works. This is -5, which is 24, -24, which is -5, and +5, and we end up with 0. There we go. Again, instead of using factorization, I'm going to jump straight into the quadratic formula. So we have negative of +24 plus or minus the square root of 24 squared minus 4 times the value of a times the value of c, all divided by 2 times the value of a. So we have a -24, and let's simplify this again with our 84. So we have 24 squared minus 4 times 5 times -5, and that's equal to, 676. And well, 2 times 5 is 10. Now, it just so happens that 676 is a perfect square. So if I take the square root of 676, that's exactly 26. So then we move this out of the way, and let's continue over here. So we have that x is equal to -24 plus or minus 26 divided by 10. And again, we have two possibilities. X equals to -24 plus 26 divided by 10, which is 2 over 10, which again reduces to 1/5. And then we have -24 minus 26 divided by 10, which adds up to -50 divided by 10, which is -5. So the zeros are 1/5, -5, and of course this number right there, -1. So there's your three answers. Now the list of possible rational zeros for number 8 starts by getting the factors of 35, which is going to be a little long list. So we have 1, we have 5, 7, and 35, and they're going to be divided again by the leading coefficient, which in this case is finally going to be 1 again. All right, so let's see what possible numbers can work. Let's see. Let's try, well, let's start with the basic one. Let's try 1. Let's see if 1 works. So we have 1, 5, -57, and 35. You know what? I don't think that's going to work. See, I don't think this is going to work because of this -57. But let's see. 1, this is 6. No, 1 times 6 is 6. And when I add that with -57, that's not going to give me -35. So not even close. So let's try something else. Let's see. Let's try. Let's see from our list. I don't think -1 is going to work either. Let's try 5. Let's see if +5 works. 1 times 5 is 5, which then adds up to 10. This now adds up to 50. Oh, there we go. And now this is -7. And -7 times 5 is -35, which again then adds up to 0. So this is what we're going to use. So with this being A, B, and C, we can now plug it into our quadratic formula and figure out the other two zeros. So we have negative of +10 plus or minus the square root of 10 squared minus 4 times A, which is 1, times C, divided by 2 times A. And let's see what this is. All right, so we have 10 squared minus 4 times 1 times negative 7. That's 128. We're going to divide that by 2. Now 128, let's see, 128 can be divided by 16, yeah. Actually, 128 could be divided by 64. Yep, we can divide by 64. So let me do some side work over here. The square root of 128 can be written as the square root of 64 times the square root of 2. And the square root of 64, well, that's equal to 8 times the square root of 2. So we can write this as 8 times the square root of 2. All I've done again is replace this with that. And now I have these three values that have a common factor of 2. So if I divide all those numbers by 2, we end up with negative 5 plus or minus 4 square root of 2, and then, well, 1. So our zeros is the 5, again, that we got by using the synthetic substitution, the rational 5, and then these two irrational zeros right there. We have negative 5 plus 4 times the square root of 2, and then negative 5 minus 4 times the square root of 2. So these are the zeros to problem number 8. And now we can move on to the last two. So the last two, for number 9, let's try negative 1. Negative 3, this is going to become 8. Negative 8, this is negative 3, and then negative 3 times negative 1 is 3, and this adds up to 0. So using A, B, and C into our quadratic formula, we end up with negative of positive 8 plus or minus the square root again of that positive 8 squared minus 4 times A times C divided by 2 times the value of A. And let's see what this is. 8 squared minus 4 times 3 times negative 3. That's equal to 100. And well, everyone should be able to recognize that the square root of 100 is 10. All right, so let's split this up now. So this again then implies that we have two possibilities. We have that x is equal to negative 8 plus 10 divided by 6. And the other possibility is that x equals to negative 8 minus 10 divided by 6. Negative 8 plus 10, that's equal to positive 2 divided by 6. That reduces to 1/3. This adds up to negative 18, or subtracts us to negative 18 divided by 6, and that equals to negative 3. So our zeros is x equals to negative 3, positive 1/3, and again the negative 1 that we got over here. So those are 3 solutions. And then it finally brings us again to our last one. So right here, we're going to list the rational zeros. Our possible rational zeros would be the factors of our last number 3, which are positive and negative 1, positive and negative 3, divided by the factors of 5, which are 1 and 5. So let's see, let's try positive 1. So 5, 51, 25, and 3. And no, that's not going to work because this is 5, which is going to be now 56 times 1 is 56, and it's going to add it to 25. So that doesn't work. Let's try negative 1, negative 5. This is now 46, negative 46, and now that's not going to be close again to giving us a negative 3 at the very end to get 0, so that doesn't work either. And I'm not convinced that positive 3 is going to work. Positive 3, that's 15. No, that's not going to work. Let's do negative 3. So this would be negative 15. And this is 36. No, that's not going to work because I multiply that 36 with 3. That's going to end up becoming 108. So no, that does not work. Negative 108, and nah. Even if I added with 35, with a positive 35, that's not going to be close to getting 3. All right, so dividing these again by 1 doesn't seem again to work. So let's see, let's try dividing it by 5 then. So let's not divide by 1, let's divide by 5. So let's start with, it can be positive, so let's start negative. Let's try negative. I think negative 1 over 5. So we're going to get the 1 and divide it by 5. So let's do negative 1 over 5. And that gives us again negative 1. 5 times negative 1/5 is negative 1. Added with the 51, that's 50. Multiply that by negative 1/5. That's going to be negative 10. And this adds up to positive 15. Multiply that with negative 1/5, and that's negative 3. And this then adds up to 0. So there you go. So one of our zeros is going to be negative 1/5. And now using our quadratic formula for A being 5, B 50, and C 15, where we're going to have negative of positive 50 plus or minus the square root of 50 squared minus 4 times A times C. Divide this by 2 times A. Let me zoom in. Divided by 10. Now let's see what this equals to. So 50 squared minus 4 times 5 times 15. That's equal to 2,200. Huge, huge number. Let's see, can we divide that by 100? Definitely divide it by 100. And that's 22. So we could break this up. Move this away. So we can break this up and write the square root of 2,200 as 100 times the square root of 22. And since the square root of 100, again, we just did that on the previous problem, is 10, we can make the substitution and replace this with that. So let's do that. All right, and let's continue this over here. So we're going to write x equals negative 50 plus or minus 10 times the square root of 22 divided by 10. And now all of these numbers have a common factor of 10. So that's going to give us negative 5 plus or minus 1 times the square root of 22. And those are my other two rational zeros. So the complete list of zeros for problem number 10 is that x is equal to that rational of 1 over 5. And then these two irrational solutions, negative 5 plus the square root of 22 and negative 5 minus the square root of 22. And that concludes again our review. If you have any questions, please send me a message on Remind or through email. And I appreciate you watching, and I hope you have a great day.